Hello everyone and welcome back to my channel. In this video, I'm going to show you how to build a fully functional weather app using Kotlin, Compose, and Retrofit. The application will connect to the Weather API service and display a real-time weather information for any city you want to type. This will include the temperature, the humidity, the wind speed, the UV index, and the local time from the city you wanted to know. Step by step, we will create the layout using Jetpack Compose, connected to the internet with Retrofit, and handle the data with a specific pattern. By the end of the tutorial, you will have a complete working application that looks clean and modern, and you will understand how the lines of code works. So let's get started. To continue, when the app launches, it shows a simple and intuitive screen. At the top, you will see a custom title that says, in my case, funny weather. Below that, there's a small search bar where you can type the name of any city you want, and at the right, a small magnifying glass icon that when you click it, it starts the search. So, as I said, once you press that icon, the application called the Weather API endpoint retrieves real-time data and displays the results right in the screen. The technology that we're using are Kotlin, that is the programming language for all of our logics here. Jetpack Compose, as I said, is the Google's modern toolkit for building declarative UIs, and Retrofit, that is a library that simplifies the HTTP request and automatically converts the JSON data to Kotlin objects. In addition to this, we will also use Coil, that is an image loading library, to display the weather icons. And we will organize the project using MVVM, that stands for Model, View, and View Model. This keeps the code organized and clean. In this case, the model defines the data structure, the view model handles the logic and API calls, and the view displays everything using composable function. Let's start with the file weatherpage.kotlin that we find it here on the left. That is the one that defines our main screen. This file contains a composable function, as you can see here, that is called weatherpage. Uh, this one handles both the user interface and the logic for displaying the weather results. Then we start with a column which vertically arrange everything on the screen. At the top of the column, we add a header um, that gives our application its identity. This make the title large, bold, and center. It's a simple change that makes the interface look good and more polished. Next comes the search section. That is a row that holds the text search field and a search button side by side. Let's break this down. We declare a state variable city using remember. This means that Compose will automatically recompose the UI whenever the user types something new. The search button then calls view model get data city, which triggers the API call to get the weather data. Finally, the keyboard hides automatically after pressing search for a clear experience for the user. If we scroll down at the bottom of this composable, we use a when expression to show different UI states depending on the network of the result. As you can see here, if the application is loading, spinners appear. If something fails, it shows an error message. And if everything works, it calls another composable named weather details, which displays the weather information. Let's move on to the weather details composable. This function takes the weather model data from the API and displays it in a clear layout. We start with a column centered horizontally. At the top, there's a row with a location icon, the city name, and the country, as you can see. This gives a nice header that clearly tells the user what city they are looking at. Below that, we show the temperature in a big bold font. As you can see, here is the code. This is the main element of the UI, clean and easy to read. After this, we load the weather icon dynamically using coil. Uh, this automatically downloads and displays an image matching the current condition. For example, a sun, a cloud, or a rain symbol. Finally, we display the condition text like sunny or cloudy, and then a card containing more detailed stats. For example, humidity, wind, UV index, precipitation, and finally the local time. Next, inside the details card, each data item is displayed using a small composable called weather keyball. These components take two strings, a key, like for example humidity, and a value, like I don't know, for example 10%, and displays them vertically. This makes it easy to reuse the same style everywhere. For example, in weather details, we can display two pieces of information in the same row. Each one looks neat and balanced. You can add as many as you want. For example, UV, precipitation, or local date and the time. This without writing a repetitive code every time. Now let's talk about how the application actually gets its data. That's handled by weather viewModel.kotlin. The view model connects the UI to the repository. It stores a live data object called weather result, which keeps track of what's going on, like loading, have an error, or successfully got the data. When the user searches for a city, get data city runs. It set the state to loading, calls the API, and then updates the state to either success or error. That live data is observed in the UI using this function here. Because compose is reactive, as soon as the state changes, the UI updates automatically. No manual refreshes are needed. So this is one of the biggest advantage of using Jetpack Compose with ViewModel. The actual API calls happens in the repository layer using retrofit. As you can see here, this is how retrofit interface look like. This defines a GET request that takes an API key and a city as parameter and return a weather response. Because this is a suspended function, it can be safely called from a coroutine without blocking the main thread. The repository wraps this in a try-catch block and return a network response, which can be loading, success, or error. The view model then observes this response and tells the UI what to display. This design keeps the application clean, testable, and easy to expand later. For example, if you want to add a 5-layer day forecast or multiple city at the same time. To continue, the file called constant.kotlin here on the left is the one that stores static value used by the application, like the base URL and the API key. As you can see here, you can put your key. You can find it on the website weatherapi.com. There you can get your personal API key. Then you paste it there. Keeping constant in their own file is good practice because it prevents duplication and keeps your code organized. Finally, before running the application and showing you how it works, make sure in your manifest, the Android manifest.xml includes the internet permission. As you can see here in this line, without this, your application won't be able to make any API calls. And yes, that's the only permission this application needs. Finally, after all the code explanation, I will show you how this application will look like on your phone. As you can see here, this is the main interface. It's pretty basic. As we mentioned before, you have your title, funny weather in my case, then the box that you can search for any location, and the magnifying glass. So if we click the box, we can search for any city, for example, Chicago. After we type the name, we click the magnifying glass. It will start loading, and it will show us. Here you have on big the city name, Chicago, the country, United States of America, the temperature right now, 16 degrees Celsius, the image that we loaded, partly cloud, and then in a box you have all the other things like the humidity, the wind speed, the UV, precipitation, local time, and the date. You can search for any city, any other city you want. Now we can go to Barcelona. Click again the magnifying glass. It will start loading again, and it will show you right now. There's raining in this case. So yeah, it works with any city in the world, and that's the final product. Thank you for watching.